Hello everyone. Today I'm going to talk to you about how to find the correlation coefficient and how to find the equation for a linear regression line. I have provided two columns. The first column is the independent variable and the y column is the dependent variable. In terms for statistics, the explanatory variable is the independent and the response variable is the dependent. So I'll type that here. Okay, so the first thing to find correlation, you are going to go to formulas, more functions, statistical, scroll down to correlation. Array 1 represents the x values. Array 2 represents the y values. Select OK. And this is your correlation coefficient R. Another method you can try is go to File, Options, click on Add-ins. You want the Analysis Tool Pack. Press Go. Make sure the tool pack is selected. Press OK. And then you go to the Data tab at the top. At the very end, Data Analysis, Correlation. Press OK. The input range is the entire table. Because I have the X and Y highlighted, make sure you check mark labels in the first row. My output range is where I want my results to go. So I will have them go here in this cell. Press OK. And as you can see, this R value for correlation matches this R value. Now, if we're doing plotting to find the scatter plot, you would highlight the table, go to Insert. We want scattered, the first one, gives you the scatter plot. You can change the title of the chart. You can also add chart elements. You can add axes titles. You can add data labels. You could add a legend if you need to. I'm going to add a trend line. You can also go over to the top where it says Add Chart Elements, Trend Line, More Trend Line Options. And at the bottom of this options, it says Display the equation on the chart. And so there's our linear regression line. Another way you can find your linear regression is you can go to Data, Data Analysis, scroll down to Regression, click OK. The input Y, excuse me, the input Y range is the Y column. Input X range is the X column. If you highlighted and included the titles of your columns, make sure you check mark labels. You want to select where you want the data to go as your results. So I want the results to go here in this cell. Click OK. And the last two boxes where it says coefficients for the intercepts, this is your equation. And as you can see, the negative 1.89 is part of the intercept here on this regression line on the chart. And then the slope 0.521 or 22 if you round is the coefficient in front of x, again on this equation. So as you can see, both approaches give you the same answer. You could also add or fix the spacing. You can say that your minimum could start at 40. And that could help with the spacing. You can do the same thing with the y-axis. You click the numbers here and you can adjust the minimum. Let's say we can bring the minimum up to 15. So that kind of adjusts your graph. Your approach is using your graphing calculator. Press on, press the stat button, press enter for edit. If there are numbers here, you can clear those out by going up to highlight the title, clear enter, go over, highlight the title, clear enter. And go ahead and type in your X and Y column, press enter after each number. And then press second y equals. You want plot 1, turn it on, so press enter. We want x values to be L1, the y values to be L2. If these are not L1, L2, you can correct them by pressing second number 1, second number 2. And then you can pick what type of mark you want. I'm just going to leave it as the first mark. And then in your calculator, press zoom 0. Oh, excuse me, I forgot to clear out my other graphs here. Zoom 0. Okay, let's try zoom 3, zoom out. Okay, if you still can't see your points, that's okay. You can adjust the window. You can just press the window button here. We don't have any negative values, so I'm going to leave my minimum at 0. And we can label our maximum at 80, and we can go by tens. We don't have any negative y values. And the highest we can label as 40, and we can go by tens as well. Hit graph. There are your points now. If you want this graph to match the one in Excel, you can adjust the window again. The minimum for your x-axis was starting at 40, and it goes up to 70. And they're going by 5s. The y minimum starts at 15 and goes up to 35, and they're going by 2s. Hit graph. So this looks very similar. You can find the equation of the line by pressing stat, calculate number 4, or you can also use number 8. They both provide the same equation. I'm going to use number 4. Double check the list. X list is your X value should be from list 1, so second number 1. The Y list should be the second column, second number 2. Frequency list should be blank. The store should be blank. And then calculate. And again, as you can see, these numbers match the values in the equation. The coefficient, 0.5218, we have here if you round. And the negative 189.39 is also listed here. And if you want to add this equation to your graph, you hit y equals. You type the equation in. X is next to the green button. And then you hit graph. And there's your equation. Another approach you can use is a longer approach, but it will work as well. We have the equation of a linear regression as y equals r sy divided by sx, parenthesis x minus x bar plus y bar. Y bar is the mean of the y column. X bar represents the mean of the x column. Sx is the standard deviation of the x column. Sy represents the standard deviation of the y column. And R represents the correlation coefficient. So we can find those values in Excel. I am going to click an empty cell. We already found R, but we'll do it again. R is equal to the correlation of X column, comma, Y column. If you don't remember what the formula is, you can find the same formula by going to Formulas, More Functions, Statistical, and then go down to Correlation, and the window will help you find your values. Select the columns that you need. Okay. The next thing we need for this formula is the standard deviations. So we need the Sx. So we're looking for the standard deviation for Sx. So we need S for sample. So the second one, you double click, highlight the column, press enter. If you don't remember again what the formula is, go to Formulas, More Functions, Statistical, scroll down to standard deviation of a sample. It tells you to select the column, press OK. We need the standard deviation of the Y column. So standard deviation of a sample. Or you can use a longer approach, Formulas, More Functions, Statistical, go down to standard deviation of a sample, highlight the Y column, press OK. Now we need to find the mean of the X column and the mean of the Y column. So equal average of the X column. Or you can also go to Formulas, More Functions, Statistical, Average, and then highlight the X column. And then we also need to find the average for the Y column. You can also do Formulas, More Functions, Statistical, Average for the Y column, press OK. Now that you have all these values found, you're going to plug these values into the formula. So it will be, let me get my stylist here, y equals the r value. I'm going to only take 3 decimal places. SY divided by SX x minus x bar plus y bar. Now, if you don't know how to simplify this, that's okay. There is a website called Symbol Lab. And you can type in this equation and it will simplify it for you. And there you go. It has these dots because of rounding, but the numbers match. There is one more approach, and I will show you the formula. This is the linear regression formula here, if you're doing it by hand. So let me copy this formula. And let's go to our Excel sheet. I'll go ahead and clear all this out as well. So here's our formula. So first we need to find the correlation coefficient R, which is the sum of the squares of xy divided by the square root of the sums of squares of x and the sums of squares of y. And they give the formula for each of those. The first one says you want to take the sum of x squared minus the sum of x squared divided by n. So we'll go ahead and do that. We'll take the x column, we'll copy it. We need x squared column. So we square each of those. And then we need the sum of each of those columns. So SSX, the sum of x squared minus the sum of x squared divided by n. So the sum of x squared was the 24,993 minus the sum of x, which was 443. We're going to square that and divide by n. N represents how many numbers in the data set. So let's count. 1, 2, 3, 4, 5, 6, 7, 8. We had a total of 8 numbers. Put this in your calculator. we get 461.875. Now we'll do the same process for the y column. So we'll do y squared. So we'll copy the y column. We'll square each of those. And we'll take the sum of each of those columns. Plug them into the formula. So SSY, the sum of y squared minus the sum of y squared, all divided by n. So it's 5974 minus 216. We still have 8 numbers. Plug that into the calculator. You get 142. The next formula says we need the sum of x times y. So we'll copy the original x and y table. We need the column x times y. So equal x times y. And then it says we need the sum of the x column, the sum of the y column, and the sum of x and y. So we need the sum of all three. So the sum of x, the sum of the y, and the sum of x times y. So the sum of x times y was 12,202 minus the sum of x was 443 times the sum of y, and we had 8 numbers. Go ahead and put this in your calculator. I get 241. Now with these 3 numbers that we found, this one, and this one, we're going to plug it into the formula here to find R. So R equals SSXY over the square root of SSX, SSY. So that's 241 over the square root of 461.875 times 142. Put this in your calculator. And then we'll compare this with what Excel gave us as an answer. We got 0.9410455,438. You can round if you want to. So let's go ahead and check it with Excel. Equal the correlation of the X column and the y column. And there you go. Now let's continue with this formula. It says now we need to find m, the slope. So our m value is SSXY divided by SSX. So that was 241 divided by 461.875. Divide that in the calculator. I get 0.5217861976. You can round as many decimals as you'd like. The next step in this formula says we need to find the y-intercept. So your y-intercept, which is the b value, is the sum of y minus the slope times the sum of x over n. So the sum of y, so you can go back up to your tables here. The sum of y was 216 minus the m value, 0.521786197.6 times the sum of our x columns. We can scroll back up to our table. The sum of x was 443. And we had 8 numbers. Put this in your calculator. Do the numerator first. And then divide by the denominator. So your b value, your y-intercept came out to be negative 1.893910.692. And then you plug your m and b into the last step, the equation for the linear regression. Your y hat is b plus mx, or you can have it as mx plus b. So the m value was 0.521786197.6 x minus the intercept. We can check this answer in Excel. Let's just double check. We're going to go to data analysis, regression. Go up to the top, highlight the y column, highlight the x column, labels, select where you want your data to be inputted at. I'm going to put it down here at the bottom. Excuse me, give me 1 second. There it goes. Click OK. And let's compare our numbers with what Excel has. So the last 2 digits at the bottom is the equation values for your intercept and for your slope. So this value here in yellow is the slope, and this green value is the y-intercept, and as you can see, they do match. So I have showed you 5 different approaches to solve linear equations by hand, by calculator, and by Excel.